Hi everyone. Just doing this question on vectors. Probably one of the most difficult questions that I've ever seen in my teaching career at the GCSE level. So let's see how we get on. Rather frustratingly, I did this question yesterday. I did a perfect take and I'd forgotten to press the record button, so I won't do that in a hurry. Part A is not too bad. Let's just start off with the information that we've got. So we're told that CD up here is this vector A, and we're told that DE is a vector B. Later on, we've got M is the midpoint of DE. So actually we've got a 0.5B there, and a 0.5B there. That's one of the benefits of having done the question yesterday. Just makes it a bit tidier. And then we're told that FC, the vector up here, is A take B, going in that direction. Okay, so we'll start off with part A, which is reasonable. So to get from F to E, get the highlighter pen out, you're going to go up there, across the top, and down to E. That's how we're going to get from F to E. Vectors is all about pathways, different pathways to get the answer. So let's do this properly. And we're going to go slow as well. This is probably the longest clip I've ever going to record as well, because the second part's going to take quite a bit of time. So FE is equal to FC plus CD plus DE. So we'll now substitute what we need. FE is equal to A take B plus A plus B. Okay, this is a bit like algebra blocking. We're blocking to the left. So the minus B and the plus B cancel out. And that leaves me with the FE equaling 2A. So we can write down here that FE is equal to 2A. I suspect if you looked at the scoring on this question, that it's quite a number of students would have got the 2 marks in the part A, but then would have struggled to get any marks in the part B. So I've already on the diagram indicated where the midpoint is and put the associated vectors in. And then we're told that x is on a point Fn such that fx is n to 1. I'll just use a capital M as it's a bit easier to distinguish. So n to 1 is the ratio on Fn. And then here comes the key line. And if you don't make this connection, the question is going to become a nightmare. So CXE is a straight line. So let's put a straight line in there. CXE is a straight line. So what does that mean for us? Well, it means, okay, sure, I've got my pens right. Some multiple of CX is a multiple of CE. If CXE is a straight line, if we multiply CE by K, we get CX. But we also know that CE is A plus B. So we can write down that CX is equal to K times A plus B. Right, we're just going to slow the pace right down here. I went to Imperial College in London, and the lecturers had a habit of doing a 25-line calculation in one line, and then you spend the rest of the evening trying to work out what they'd done. Okay, so let's see if we can work out an alternative version of CX, which is going to involve going down this vector Fm. So let's work out the vector Fm first. So Fm is A take B up there, across the top, so plus a CD, so plus an A, and then down DC halfway down at 0.5B. So we've got two positive A's, so that's 2A, and we've got minus B plus a half B, so that's minus 0.5B. I mean, as well as being conceptually difficult, it's technically difficult as well. So what's our alternative version of CX then? What's our second version of CX? Oh, we're going to go the opposite of this vector here, so minus A plus B. And then we're going to do n of n plus 1 of Fm. So we're going to go n of n plus 1 of Fm. So we've got this version of CX, and we've got this version of CX, and what we're going to do is we're going to equate the coefficients of A and B, and that's going to set us up with two simultaneous equations which we can use to find n. So equate coefficients of A and B. So the CX there is K A plus B is equal to minus A plus B plus n over n plus 1 of 2A take 0.5B. Now, you're going to have to be very careful here. So when I say equate the coefficients, we're looking at the numbers in front of A, and then we're looking at the numbers in front of B, numbers or letters. So in front of the A on the left-hand side is a K, and then in front of this first A here is a minus 1, and in front of the A here is a 2n over n plus 1. We now do the same for the B. So again, we've got a K. And in this occasion, we've got a 1 there. But this time, we've got a minus 0.5 n over n plus 1 in front of my b. Let me just double check that because there's a k, there's a 1, there's my n over n plus 1, there's my minus 0.5n. And because these are both k, we can let them equal to each other. So we can say that minus 1 plus 2n over n plus 1 equals 1 minus 0.5n over n plus 1. So let's do a little bit of tidying. I say to my students, algebraic familiarity would tell me to multiply through by n plus 1. So we'd get an n plus 1 there. We'd get an n plus 1 there, which would cancel there. Get an n plus 1 there. And we get an n plus 1 there, which would cancel with that one. So that's multiplying every term by n plus 1. So just being careful again, so that's minus 1 times by n plus 1 plus 2n is equal to n plus 1 take 0.5n. So we've turned this into a more straightforward linear equation. Bit of tidying here. Minus n minus 1 plus 2n equals n take a half, that's a 0.5n plus 1 here. That becomes n take 1 is equal to 0.5n plus 1. I'm doing that thing where I'm not actually explaining my balancing, but I think at this level you don't need to. Taking 0.5n from both sides gives 0.5n, and adding 1 to both sides gives 2. And then dividing both sides of the equation by 0.5 gives me an answer of n equals 4. And that, would you believe, is the answer. I think certainly in the top 5 most difficult GCSE questions of my teaching career. 13 minutes 12 seconds, tough marks.